Okay, we're going to have a go at the modeling part now, which can be quite challenging. So certainly one that needs to be practiced quite a bit. But this is the final part of chapter 8. Here we go. A plane's position after takeoff can be modeled by the parametric equations. X equals V. Don't really know what that is yet. Cos theta. We suspect, maybe if you've done some mechanics, that might be something to do with the angle that takes off, that it might be fixed. Theta might be fixed, but we need to keep an eye on that because theta sometimes is a constant in the question and sometimes it's a variable. So we need to keep an eye on that. T is often the third parameter, isn't it? So that's probably what that's going to be, but let's keep an eye on it. And the same sort of thing here, but with sine. And again, if you've done mechanics, that won't surprise you that it looks like that. So we need to be quite careful here in understanding how V and theta and T, how they operate. M is just meters, okay? The restriction on T is only that it has to be bigger than 0 because it's after takeoff. Let's go through. So V is the speed of the plane. Theta is the angle of elevation. X is the horizontal distance. Y is the vertical distance relative to a fixed origin. Okay. So when the plane has traveled 600 meters, so when you've got 600 meters there, it has climbed 120. Find the angle of elevation theta. So the wording and the theme of the question lead me to believe that the way theta is operating here is it's going to be a fixed value. So if we work this out, we'll be able to use this later. So how can I find that angle with that right angle triangle? It's got something to do with tan, hasn't it? So tan theta is the opposite side, which is 120 over 600. And then I could just find my angle by doing inverse tan of that. So to save us a little bit of time, I'm going to just pinch the answer from here. Okay, so there we go. That should end up being 11.3. So now I know that. Yeah, I know that's 11.3. So this bit here then is going to be like cos of 11.3. And this bit here is going to be sine of 11.3. I would make the suggestion that you press the STO button on your calculator and then press A, and then your calculator will say something like that. And it means that the number's ready for you to use because you might have to use that quite a bit. Given that the plane's speed is 50, it is 50. It doesn't say it's 50 at this point. It just says it is 50. So what's that suggesting? It's suggesting that that's just a fixed number again. And if we go back, the plane's speed was V. So this bit there then is going to be 50, and that's the same. It's the same letter, it's the same V. It's 50. So we can clean that up a little bit. So we can say this is 50 cos 11.3. I just want to make it nice and obvious that the T is on the outside. Okay, so something like that. So I can do the same for the other one. So it's going to look very similar. 50 sine 11.3 T. And let's just check that we left it the same way. Yeah. So you could put this in a calculator if you wanted to, and you have a number, but it might be more precise if we just sort of leave it as that for now. So that should be fine. These are our parametric equations then, because they're ready for us to use. X relies on giving it a value of t, y relies on giving it a value of t. So in other words, if I gave you a value of t now, you'd be able to work this stuff out, which is the kind of thing that we want to be able to do. So find the vertical height. Vertical height, this is about y then, isn't it? After 10 seconds. So you're just going to put the t part as 10. So it's 50 sine 11.3. And then you're going to multiply your answer by 10. And again, I'm going to pinch the answer for that one there. So if you do that, you should end up getting 98 meters, hopefully. Okay. Right. Let's keep going. Show that the plane's motion is a straight line. Okay. So, right, what was I gonna say? A straight line. So as it continues, it's going to keep this angle then. So we may have suspected already that it has a straight line. So what would be a good way of doing this? Well, one way that we might want to do it is we could try making it a Cartesian equation. So we could try eliminating the t bit, and we could see with the y's and the x's perhaps what's going on. So that would be a good way for us to do it. Now, what's going to be the best way for us to do that? Well, substitution. We should try substitution first. So I'm going to try and keep the y equals bit, which means I'm going to play around with the top line. I'm going to rearrange the top line. So I'm going to say t equals well, what would it be? It would be x divided by 50 cos 11.3. And then I could substitute this result into there and take a look at what I got. So let's do that. So y equals 50 sine 11.3 multiplied by x over 50 cos 11.3. Clearly the 50s are going to cancel, and you end up actually with y equals sine over cos of the same thing. You end up with tan 11.3 x. So y equals mx. The c value is 0, which makes sense because they said it was sort of starts at the origin. So you clearly got the format there of a straight line. So that's one way that you could show it clearly. But you may have suspected that already, given that we were saying that there's a fixed angle. Okay. Explain why the domain of t. So you may have noticed I tend to not say domain around t because it gets very, very confusing. But the idea actually generally is the values that you're allowed to put in that things are a function of, that's actually called the domain. So why is it not realistic to put in any value into these other equations, basically, that is bigger than 0? Well, it's good that it's above 0 because it's after takeoff. But this situation is unrealistic. Why is it unrealistic? Try and use the earlier parts of the question to help you think about it. It says it's going in a straight line. Forever? Push things to the extreme. When you're trying to think of limitations, try pushing things to the extreme. So there's no end point, is there? There's no end point. So there are a couple of issues with that. So one issue is it never lands. It's going into space, presumably. It's going to run out of fuel at some point, so it can't keep that up. So all of these would be valid answers. The closer you can link your answer to the context of what's going on, generally the safer it is. So I would try and mention the fact that it's a plane. So I would say it assumes that the plane never runs out of fuel and that it keeps rising forever. That would be a very, very safe answer. In fact, if I have a look at the recommended answer, it says the plane would continue to climb forever. You know, that's a pretty good answer, but you might want to just think about kind of overdoing it. More is better for those kind of questions, to be on the safe side, because they are marked quite harshly. Okay, so lots of letters in that one, and we had to work out which one was the third parameter, which was t, because sometimes it can be theta. So don't assume that theta is always just some fixed value. Sometimes that's the third parameter. Speaking of which, I think we're going to have a go at this one here. So just a word of warning, this is not the nicest question in the world. So this one's a little bit tricky. The motion of a figure skater, so that's like somebody skating on ice, relative to a fixed origin, at time t minutes is modeled by these equations. T is allowed to be anything 0 or more, so it's just going to go on forever. Yeah. Now, I'm going to look at the picture and try and use the picture to try and help you think about what's going on. So what can you see? And try and break down what can you see to thinking about the x direction and the y direction separately. So what can I see about, this way around here? What can I see about the x direction? Roughly, it seems to sort of go, the most negative it goes is something after -5, -6, 7, 8. Seems to be about -8. And how about on the right? Do you see that that also seems to be the same number? So why is it doing that? Well, it's in the algebra. So if you're allowed to put any value in for t, and you are here, cos is going to go 1, 0, -1, 0, 1, -1, 1, -1, 1, -1. So it's going to give you all of those values in between that. And you're multiplying it by 8. So it's actually 8. Starts off at 8, 0, -8, 8, -8, 8, -8, 8, -8. And it's your x equation. So that 8 and -8 will mean that your whole graph is contained between 8 and -8. So that's why it's doing that. You can do a similar thing with the y part. Look at the height of it. The highest point, by the way, doesn't seem to be there. It seems to be about over here somewhere. So where is that? It's about 12. So why is it like that? It's like that for the same reason. Now, I don't really care about that bit there or that bit inside. That's not really affecting the range of values that you can get. It's just affecting when you get those values. So sine is 0, 1, 0, -1. So it's 1, -1, 1, -1, 1, -1. And you're multiplying it by 12. So it's 12 - 12, 12 - 12. And it is, in fact, the y direction. So the whole graph's between 8 and -8 that way. And it's between 12 and -12 that way. So it's a bit like you can sort of fit this whole picture inside a box. Yeah, you can fit that inside the box of 8 to -8 and 12 to -12. Okay, you might think I'm going on about this a little bit, but this is a section that students really, really find very, 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 very hard, and it stops people getting into a lot of the harder marks. Okay, a lot of the stuff is about domain and range. Anyway, find the coordinates of the figure skater at the beginning of the motion. Beginning means what? It means the same as initial. It means t = 0. So t = 0 needs to go into your equations. So x equals 8 lots of cos of 0. Cos of 0 is 1. So this is just going to turn into x equals 8. So the figure skater starts, I don't know exactly where. It's either there or it's there. I don't actually know which one it is yet. Y. So do the same with y now. Y equals 12. Y equals 12. So the 10t bit is 0. So sine, yeah. But there's that -pi/3 thing. So I need to watch out for that. So what's that? That's 60, which would be √3/2. So it's going to be -√3/2. So multiplied by 12, it's going to be this point here. Okay, so if you work that out on your calculator, again, I'm going to save a little bit of time because I don't have my calculator in front of me. Where is it? There we go, at the top, that one there. Okay, so that would be your starting point. So it was this one over here. Okay, so t is 0. Very, very easy marks. If you just write them out with the t bit 0, you're going to get at least the first mark. Find the coordinates of the point where the figure skater intersects his own path. Well, what could they be talking about? It looks as if it's that one there. Now, they do something a little bit unusual on this question. So you're allowed to use, you're supposed to see that that point there is -4. Okay, so we can see that that's -4 and we can see that's -4, 0. Now, we've been given the x and the y part on that one. So find the coordinates of the point where the figure skater intersects his own path. Right. So I seem to remember a bit of a strange question. So I think you're supposed to see that it has clearly crossed the x-axis, but the idea is you might not be able to see that it's -4. So I'm going to take a quick peek. Yes. So that's what they're getting at. So a bit of a weird question, this one. I know you can see it's -4, but they're pretending that you can't see that. They're pretending that you can see, though, that it has crossed the x-axis. So if it has crossed the x-axis, you would know that y is 0, wouldn't you? What do you do with that? You can use y is 0 to find a t value by playing around with this one here. So 0 equals 12 sine 10t minus pi over 3. Divide both sides by 12 will be the first part of doing that one there. You can do inverse sine of both sides. So inverse sine of 0 equals 10t minus pi over 3. Inverse sine of 0 means when does a sine graph give you 0? It gives you 0 at 0, but it also does it at pi radians and, you know, thereon after. Okay? So I'm just going to do, if in doubt, you can maybe write a couple of values, but there seems to just be 1 point. So I'm just going to do a couple of values. Okay. So 0, pi, 2 pi, it will happen then. So that equals 10t minus pi over 3. If I add pi over 3 to both sides, I get pi over 3. What's this one going to be? It's going to be 4 pi over 3. Right. Actually, I don't need these other values, okay? Equals 10t. And then if I divide by 10 on both sides, I get t is pi over 30. And I'm just going to use that value. The reason why I've just written some other ones there is because I've been solving with a few more things going on. So I was just doing that because I wanted to make sure I got a positive value of t. If you're wondering why there's lots of values because the person's going around and around and around. I should be able to use any of these values and get the right answer, by the way. But I'm going to just use t equals pi over 30. So now I put that into the x equation. So x equals 8 cos, and then this is 20 times, it was pi over 3, I think, wasn't it? Pi over 3. And if you do that, you should end up getting, let's just double check, you should end up getting -4. Okay. So -4, So a bit of a weird question because you can clearly see that it's -4, but imagine if there were no numbers on the axes, we would have to use the fact that y is 0. Find the coordinates of the points where so there's more than one, points where the path of the figure skater crosses the y-axis. Right, there is a lot of them, isn't there? So I'm expecting multiple answers on this one. What does it mean visually? It means when x is 0, doesn't it? So when is x 0? When is x 0 on this one? I'm going to get rid of this because this is getting in the way a little bit, this stuff, okay? And I don't think we actually need this for the next part. So x is 0, right? So x is 0 means 0 equals 8 cos 20t. Divide by 8 both sides. Inverse cos on both sides equals 20t. Now think about what we just said. We need lots of values here. So I'm going to need to find multiple times when cos is 0. So when is cos graph equal to 0? Well, something interesting happens every 90 degrees. So the first time is going to be pi over 2. Then when is the next time? So that's pi. So this is 3 pi over 2. And you keep adding a pi. Yeah, because you'll go up half pi, down another pi, down, up. So it's going to be something like this. And I'm going to do 4, aren't I? Hopefully you can see why I'm going to do 4 of the solutions. But it would keep going and it would keep going and it would repeat and it would repeat. So equals 20t. Now I divide by 20 on both sides. So I get 40, 40, 40, 40. Those are my t values. And what am I going to do with my t values? You've guessed it. I'm going to put them in the other equation, which is left, which is the y equation. So these are each going to go, let's get rid of these old bits here. These are each going to go into the y equation. So y equals 12 sine 10. And you're going to substitute your answers in here, okay? 10, because these are the t values. 10 of that minus pi over 3. And then you're going to use the arrow keys on your calculator to go back and forth, and you're going to change them, okay? That's practically what you're going to do. And if you do that, you should get the following answers. Okay, but this is going to take you a little bit of time. So I'd expect you to have it all laid out properly and be working through that. Okay. Now let's get on to the tricky bit. So how long does it take the figure skater to complete one complete figure of 8 motion? Now, there's a lot of ways of answering this question, but the way I want to answer it is by looking at this part here on each of them. So I'm going to ignore this part here, because that kind of tells me like the value at the start. That kind of shifts things, but it doesn't affect the wavelength. It doesn't affect how long it takes for things to repeat itself. So I'm not overly concerned with that bit there. Instead, I'm going to be thinking about this 20t and this t business to help me do this. Okay. So if I think about a normal cos graph, like the one on the right, for example, it completes itself over 2 pi, doesn't it? Okay. So over the course of 2 pi, it will do a full sort of sweep of all of the values. Now, when you do 20t to something, what are you doing? Well, you're inside the function, it does the opposite sort of. That's what we said. So it's not going to be 2 pi. It's going to be quicker than that. It's going to be 2 pi divided. So this is for the x part. It's going to be 2 pi divided by 20, which is pi over 10. So that's going to repeat itself every pi over 10 seconds. What about the y part? Well, it's sine, and sine has the same idea. 2 pi in general is how long it takes to complete a full cycle. But you're multiplying that by 10, so that kind of ends up dividing this one here by 10. What's that the same as? That's the same as pi over 5. So you've got one thing doing its like full set of values every pi over 10. And then you've got the other one that's going a little bit more slowly, okay, that's doing it every pi over 5. So when will that all sync up together if you've got two things working at a different speed? What you want here is you want the lowest common multiple. You want the lowest common multiple. This is the same as, if you remember from GCSE, it's the same as like a bus that is every 4 minutes. So it's like 4, 8, 12, 16, 20. And then you have a bus that's every 5 minutes, and that's 5, 10, 15, 20. Yeah, you want to find the time that it takes for them to link up. It's 20 here, by the way. So how long will it take for it to link up? It's going to be based on those two wavelengths there. And I think they've done the same approach on here as well. So if we go with the larger of those, yes, they've done the same approach. So if we go with the larger of those, it's going to be pi over 5 seconds. Okay, because in that time, X will have done its full set of values, and then it will have done it again, and Y will have done it as well. Okay, so it's pi over 5 seconds. So like I said, that's quite a sort of, that question is quite a bit more difficult. I suppose you could have done that differently by finding a particular point and solving it for x and y and showing that the gap in the values of t is pi over 5, but that's a very, very slow way of doing it. Okay. Anyway, let's recap on this section. So what we said is for modeling questions here, we have to read through it very carefully. We have to think about restrictions of t. We have to think about, are they parameters? Are they constants we need to find? And really, we're encompassing all the skills from before. We've got Cartesian equations in there with lots and lots of substitution. We've got using an x to get a t to get a y to get a t to get an x. Okay, so those are probably two of the most common skills. The only thing we didn't really have to do there is we didn't have to do any complicated identities to make a Cartesian equation. Time to do lots and lots of practice. That's the end of chapter 8.